Okay, hello and welcome guys to another stream of network programmability. This is Dmitry and we had a break for a while, so there were 3 weeks without any stream. Now we are back. The main reason why we didn't have any stream because I was in Barcelona at Cisco Live, so I didn't really have any chance to record a stream on Sunday. Okay, so there are a couple of questions that I would like to answer. So yeah, as you can see guys, I'm using a different camera right now. I hope that for the next week I will fix it, but for now I will have to use my laptop for this. So a couple of questions here. If my project is on the GitHub, yes, my project is on the GitHub page. You can find the link below. On my GitHub page, it's called Network Programmability Lab, if I remember correctly. Another question. What's the name of your text editor? So I use a couple of them. I use PyCharm is my main text editor for Python, and if I need to have a text editor, not full-blown IDE, I use Visual Studio Code, which is here on the back. Let me make it a little bit smaller. So this is my main text editor, and PyCharm is my main IDE for Python. PyCharm, it can be free. There is community edition, not with all of the features, but it's pretty good as well. And if you need more advanced features like integration with SQL, with Django and so on, you can pay for professional edition. But community edition is pretty good as well. Okay, so let me talk briefly about the agenda for today. As you can see, let me bring my GNS3. You can see that the lab for today is different than my usual big lab. So on 2 or maybe even 3 previous streams, we were playing with netbox IPAM system. So yeah, at least 2 streams for 2 streams we use we were covering a netbox and their API, and then we reached to the point where we can do something in netbox, like define prefixes, devices, VLAN, stuff like that, and then using their API we can extract this data in Python and then configure network devices using this information. So basically we are making our netbox IPAM system a single source of truth, which is pretty good. So for today though, I decided that because I had the break, I would still need time to kind of remember what I was exactly doing there and at which point I stopped. I decided, okay, I will do something different for today. And one of my router gods colleague had a task basically where he had to extract MAC address tables for a lot of switches in his network, and they are legacy switches, so they cannot use new stuff like netconf, restconf, so we would need to use CLI for that. And he wanted to sort those MAC address tables based on interface. So I decided, okay, I actually want to do this for you, and I will do it on the stream for you. So I think it falls nicely into what I'm doing on the streams. So I decided that it would be interesting for people to see. So basically I built a network in GNS3. You can see here there are PCs that are represented as routers. So there are packs of 3 PCs connected to one switch, and there are in total 12 PCs. On the left hand side, here on the left hand side, this is my management network. So there is a NAT cloud, there is unmanaged switch, and all of the other routers and switches are connected to this unmanaged switch. The reason why is that I can go to the machine behind this cloud, and this will be my management station. So I can, run scripts, I can run Ansible playbooks for there, all of the stuff that I need. And then so basically the left hand side is this management network, and on the right I have basically here these 4 access switches. So access switch 1, 1, 1, 2, 2, 1 and 2, 2. So access switch 1, 1, 1 and 1, 2 are connected between each other, and 2, 1 and 2, 2 are connected between each other. And then they are connected to another unmanaged switch. In this case I called it distribution switch, but doesn't really matter, it doesn't have really CLI. And in the middle I have a router which does basically router on the stick. So my switches are working as pure layer 2 switches. They have VLAN 10 and VLAN 20 for the devices. We trunk them across this distribution switch to the router, and on the router, let me bring up CLI. Or maybe I didn't have it. Oh, I have it. So here I have LAR1, and I have basically 2 sub-interfaces, .10 and .20, to 2 router on the stick for these VLANs. I know this, like, you rarely see router on the stick in real networks right now. Most of the time you would terminate the VLANs on switch, either access layer switch or distribution layer switch. But for the purpose of this lab, it doesn't really matter, because the only thing I want to collect MAC address tables from the switches. So another thing that I did, I configured here on the router 1 DHCP. So all of the PCs are getting the IP address from the pool on the router 1. And if I go on PC1, for example, if I look on the IP address, it has IP address 10, 0, 10, 20, and I can ping other devices. Then let's say 21, 22, and so on. So those are computers in VLAN 10, and there are computers in VLAN 20. So let's say 20, 20.20, 20.1, and so on. So basically I created some kind of like mock-up network with a couple of VLANs, and I'm doing router on the stick. So yeah, the question is Python plus network. Yes, because I'm a network engineer, I will be doing stuff mostly related to networking. Okay, so yeah, let's start. Yeah, so as I told you last week, I was on, well, actually it was already 1.5 weeks ago. So yeah, 1.5 weeks ago there was Cisco Live 2018 in Barcelona. It was a really great experience. I will tell you more during the stream, but I would actually encourage you to ask questions if you would like to know something more specific rather than me just describing the event. It would be much better than we have this kind of interaction. So while I will be doing the lab, feel free to ask either about Python or the stuff that I'm doing, or regarding Cisco Live. So maybe, yeah, you would like to know something. So what will be the plan for doing this? Actually, I think on the very first stream I did similar stuff. Basically I was going to devices and collecting some show commands and just returning them. I think this would be a good refresher to start doing that in like using typical Python synchronous style of programming where you connect to one device at a time, not simultaneously, and then you collect output, you return it somewhere, then you connect to another device, and so on. And then after we will finish with that, I will show you how we can do it more efficiently. So there are a couple of ways to do it. So one way would be threading to do concurrent programming. Another technique would be asynchronous programming or asyncio. Yeah, and, this is basically agenda for today. So let me start first by going into my my terminal here and activating my virtual environment that we used throughout the whole throughout all the streams that we had so far. So I think it was netdevops. Yeah. So I do source being activate, and now I'm in netdevops virtual environment. Let's remind what libraries we have there. So we have important libraries for today will be netmiko, then requests, maybe not yet 100% sure. Then we will have netdev library, very important one for doing asynchronous SSH connection to network devices. And for now, I think that's all that we really need for today. Okay, so let me go to my PyCharm here, and let me start by creating a new Python script. So I'm creating a Python script. Let's call it collect MAC address tables. Okay. So let's start with the boilerplate where we would like to wrap the main function into this under name construct, so that if somebody imports this module, this script is not run, but if you run it directly, then the main function will start. This is a typical idiom in Python. So okay, this is what we will have. So we will definitely be using netmiko library. And there is one new library that I discovered recently called Python decouple. Let me find it. Python decouple. And let's open a couple of links here. So this library is mostly used for Django projects, but it's alright to use it for different projects as well. So look on this blog article where basically the typical problem is Alejandro, thanks for following. So the typical problem with any kind of project is you have some secret information that most likely you don't want to commit to a Git repo, especially if it's public one. So for example, API tokens, some credentials for devices, stuff like that. Usually you don't want to commit those to Git. So there are a couple of ways how to deal with this. One typical way is to have this API tokens as environmental variables, and then you use os.environ method where you can extract whatever environmental variable you have. So then you don't commit environmental variables obviously to Git, you define them as part of your environment, and then Python script can use them. Another way to deal with that is to have some kind of either .ini file or like some Python file which you add to git ignore, so and so that you don't commit it to git, and then from your main script you import that .ini file or Python script, and you use those variables. So this is also a very typical approach to do that. But just recently I stumbled upon this library, and I think it's I think it's amazing. I actually didn't have a chance to try it yet, but I looked on their documentation and I was like, okay, this is exactly what I need. So, oh, I'm sorry. So here is what they do. When you have this library, and so here is, they show an example from Django, where you have a secret key in Django, you have some other database password here. This is a typical settings.py file in Django. And then to bypass this, you create .env file as part of your directory, as part of your project, or .ini file. And you define the same variables basically. You as well add this env file, and then you use from the couple import config, and then you replace those secret values with config, and to the function you pass the name of the variable. And very important point, if for some reason some of these variables you have as environmental variables, they take precedence. So you can have environmental variables that take precedence over your .env file, and then in env file you have some additional stuff. So basically you kind of have a unified approach to reference variables that are environmental variables, or they're in the file, in this case in .env file. So I think it's pretty cool. So this is what I will try to use. So let me install this library first. It will be pip install. Good question. Is it Python minus decouple? Yeah, it's Python minus decouple. Python minus decouple. Okay. Awesome. So the person that that had this task to collect marketers tables told me that they use one single pair of credentials as part of, I think, TACAX. So you do .1x for remote login. In this case, I will obviously not use TACAX. There is no reason to overcomplicate setup, but I can create a, let's say, .env file. Let's see, we'll create actually in PyCharm. In the root of this .scripts, I will create .env file. It will be text, and where I say, let's say, username is, so this will be credentials for remote login to devices. I will say username Cisco and password is Cisco. And then for devices themselves, we will need to use, we will have to provide a list of IP addresses. So I think we will also need to basically to add list of IP addresses. We will need to also specify them somehow. In this case, I will be using another file. Let's have maybe YAML file. Let's say MAC address table, or let's say MAC address table inventory.yaml. And here we will have a list of IP addresses. So, and those will be my my IP addresses of switches that I'm going to query. so let me think what will be the best way to have them specified. Maybe like this, switches, and here will be just a list of IP addresses. So and I obviously forgot the IP addresses, so I have my 4 switches. Let me see. Okay. So I have my 4 switches right here, and this is YAML file where there is a key switches, and then there is a list of 4 IP addresses. Let's see if this works. So I will need to import YAML, yeah. And then let's see, let's have a function dev read YAML. I think we already did something like this before, but that's alright. Let's say here we will read YAML, and we will provide a file name. So let's say file name. And here's the file name will be, let's say inventory file will be MAC address table inventory.yaml. And here I say read YAML inventory file, and then I have to open the file name as f, and I forgot the function for YAML. Let me consult documentation. So Python YAML, by YAML documentation, from YAML import load stream. Okay, I can just pass. Let's say result will be YAML.load f, and then I return result, and here I will just print this. Okay, so and let me run this code. Run collect MAC address tables. Okay, this is exactly what I needed. So I have key switches, and here is a list of IP addresses. Awesome. So let's now have a function which will be, let's say, read inventory YAML. Say inventory YAML, and file name by default will be inventory file. Okay. So the next thing I want to get will be list of IP addresses. So get device, let's say IP get let's say switches IP addresses, and this will be an empty function. So what this is going to do, this is going to return read inventory YAML, and then I return switches. And now I can say print get switches IP addresses. Okay, see if this works. Okay, cool. So this part works. So let me now use netmiko to connect to devices. So unfortunately I don't remember on top of my head, so it's also consult their docs, netmiko docs. Latest docs. Base connection. No. Okay, from netmiko import connect handler. And let's also, just for the test, have another one which is called test IP addresses, and this will be another one. So remember that my lab setup, my lab server is remote, and this is where I run all the labs, so I will not be able to run my scripts from my local computer to access devices. I still haven't built the VPN. I have to do it at some point. So I can either use some different devices for tests, or I can commit code and then git pull on my lab server and then run scripts from there. But for now I think I will just put I have a couple of CSR routers that I can run the same thing basically. So those two. To those devices I have access directly from my local machine, so I can until I prove that my code works, I can use these devices for test. So let's say IP addresses will be this, but for now I will comment this out and I will say IP address, let's say IP list. This will be test IP list. Okay. So let's see what our docs say. So I have to specify this dictionary, blah blah blah. And then I just pass this dictionary and I say send command. Okay. I will copy this. So let's have get output function, which takes an IP address and command, and that's all. So let's say I have let's say so we will have to create a connection first, and there is no reason for us to recreate the connection. Let me think this through. Let me just try this code here in main first. So device params, device type is this. I don't need verbose, I don't need secret, so I need only device type. Oh, I need IP, username, password, and device type. So let's do this. Let's have global device params. Remember, our username and password are the same for every device, so we can use that decouple library that I was talking about before. From decouple import config, and then config dot something. Config and in parentheses username. Okay. So this will be config username and then config password. So this part will be different. So now for every device, for IP in IP list, I'm going to create device parameters dictionary. So this will be a copy of global one, copy, and then device params IP will be equal to IP. And now I can create a connection, so I can say connection, say SSH connection, or no, let's have device connection will be connect handler, and I have to unpack this device params. And then at the very end I will have to say device connection.disconnect to close the connection. You know what, let me check something. I'm thinking if there is a this statement for which does disconnect automatically, and I'm not sure it does, so let me check in their GitHub repo. So use netmiko connect handler ini.py connect handler netmiko SSH dispatcher right here. Dev connection handler SSH dispatcher device type. I don't see what I wanted to see, so I expected maybe base connection. So I'm looking for if this supports this statement, and I think it doesn't. Yeah, you can use Paramiko, but honestly, there is like netmiko is a little bit has a little bit cleaner syntax because you don't have to like read bytes. You can just say like send command, send config and stuff like that. So I prefer using netmiko when I interact with network devices, but feel free to use Paramiko as well. So okay, I don't see here the under enter. So if you use Google for Python context manager, you would need, if you want to do context manager, and context manager is, let me show you. So when I say here viz open something, it's context manager. So the way it works, it does something when you run viz, and it does something when this block ends. So it can clean up some, like if the file was open, it will close it. So thinking that netmiko also supports this, but it seems it doesn't, and I have to clean up my SSH connection manually. But that's alright. And the way you would do this for your custom classes, you would have dunder enter method and dunder exit method, and this just doesn't open. Okay. Context sleep. No, I really need this one to open. Let me try from duck.go. So Python context manager. This also doesn't open. Okay. How to make a sandwich using Python context manager. I like how this article is called. Let me scroll, because the only thing I want to show you is here. Yeah. So here they created a new class called ingredient, and at the very end they have dunder answer method and dunder exit method that does something. So usually in these methods, especially in exit method, you would clean up whatever connection you may have. But it seems that Paramiko doesn't support it, but it's alright. Okay. So after creating a connection here, I would need to collect the command basically. So I can say command, let's just do for the test result, or no, let's say command output will be device connection dot send, I forgot how it's called, netmiko docs send command. Okay. And then you would say I want to have command, let's say show version, and then I will also print this command output just for the test. And now this is supposed to work. Allegedly. Oh, and it works. Wow, from the first attempt. This is amazing. So I collected an output from my test devices. Those are CSRs. Okay, this seems to be working as expected. So now you have to modify it, and you have to be quite careful with how we do this. So you'll need to collect two commands for MAC address table task. You'll need to collect the show version to get the host name of the device, which is right here on this line. So before uptime you can get the host name, and then you would need to collect show MAC address table, so that you can, like, in the output you can put host name of the device and then MAC address table itself. So those will be two commands. So let me think. The hostname one we will have to parse. MAC address table we will also need to parse. I mean, I can obviously like put just here 2 comments on different lines and be done with this, but I want to put something better than this. So there is really no reason from this function, because we already have one function which gathers an output here. This is really useless. But let's say we have dev get MAC address table and you pass an IP. Let's say host. And then this will do very similar stuff. So I copy this and I say here host, do connection handler. Now I will have to do additional functions. So I need to do get hostname function, and this will take an output from show version. So let's say a CLI output. We will need to have regular expression. So let's say hostname regular expression will be, you'll have to also import a array library, and I will put it on top here. So okay, hostname array. So I will create a regular expression object, and this will be p, and this will be hostname, and I have to specify that I'm looking for this line. And just for the test, let me copy this and do regex 101, no, regex101.com. Okay, so test string is right here. I use Python, and I will be using named groups. Hostname. This will be, it starts with the line, and this will be hostname may have underscores, minus, it can have anything really except of spaces. So let's say \s plus, here will be \s plus, small one, so this will be white space character, and then uptime. And I will have to also specify that I'm looking for multi-line, and now I got this hostname. And then I also need to specify a flag. And I forgot how to specify flags. Python regular expression flags. I think it's just this comma like this. So for multi-line and multi-line one recognizes caret and $sign as a start and finish of the line for multiple lines in the output. Without this one, without red.m, this character will match only beginning of the string and end of the string. Now I'm matching beginning of the line and end of the line. That's why I need red.m. Okay, this looks good to me. So let's do get host name. So to get the host name, I will have to say let's have different one. Let's have parse host, parse show version, and then we'll say hostname red dot search for the CLI output, and then group dict. And so this will be result, will be dict, and then the result dot update will be this one. So when I say group dict, it returns key value parse. So in this case, key will be hostname and value will be the hostname itself. This will be a dictionary, so this is what group dict function returns. And now I am adding this to like an end to my final dictionary using update function, and then I return result. The reason why I do it that way is because we might have multiple regular expressions. So let's say I will also say this image file. This is useless for our purpose, but it may be useful for like your parsing. So I need to match. I also want to find this one. So let's try in our regular expression regex 101. So okay, I need to get boot image, and it will be a little bit different. So I have to escape the quotes and okay, and it starts with system image file is, and then at the very end there could be some ending characters, so I'll put \s. Okay, this looks good to me, and we'll have another one here. It says, and because I'm using single quotes, I don't need to escape double quotes anymore. So I can do this, and now I can say update image rel. You can even go one step forward where you can have, yeah, this will be even better. So you can have show version regex, and this will be a list. This is what actually I did for one of my projects. Well, there was even more complicated, but is an interesting approach here. So I have show version regexp, let's say regexp list, and now we can say here that for regexp in show version regexp list, you can have regexp.search group dict. Yep. So, and then it should work, and there's a mistake here. So let me see if this works. So I have two regular expressions, one of which parses the host name and another one gets boot image name. So what is happening here? So show version regexp list, partial version. So let's say result will be and we'll say parse show version, and I get this output right there, and then I will print result, and then we use this get MAC address table function for every IP, and allegedly it should work. Which it does. Okay, so I got host names and I got boot images, this thing like this. Pretty cool. Okay. So that's alright, but we also will need MAC address tables. And let me see if I have an example. Show MAC address table. So I have this one. This will be my example. Now I need new scratch file. Let's say plain text. And the task was I have to get this table for every device, and I have to sort the entries by interface. So I have to parse this thingy. Thinking how to do it the best way. So one way would be to like parse everything and then reconstruct the whole thing. I can do that. I think this is what I actually should do. Yeah, I think this will be alright. So for MAC address table, we'll have to do a little bit more creative. Let me get this and pass over regexp stuff. By the way, if you do a lot of regexp for network stuff, you can use TextFSM. I don't want to use TextFSM for now, for this specific task. I actually don't like their documentation and the way their API works, even though it's quite handy for one of my projects I wrote my own parsing engine using regular expressions where you could put unfortunately I cannot show you exact one, but it was something like this. There was a JSON file where there was a key, the name of the command, so like show version, and the value were a bunch of regular expressions plus some flags, so like for multiple and for non-multiple ones, and then the engine takes just a command as an input and it returns key value pairs. I think that was pretty cool. So it kind of like text FSM, but I think it was a little bit more Pythonic. So if you don't know what is text FSM, let me show you. I'm not going to use it for my project, but I think it's useful. I hate when the main page doesn't have an example. Let's do this. Programmatic access to CLI devices with text FSM from JSON. Edelman. Yeah, so here is the FSM template. You specify a variables on top of FSM template, and then you specify the file itself. There are also some specific commands like record and some other stuff. You define your regex like this, and then it returns to you the also like key value pairs, if that's what you want. Okay, but as I told you, I don't want to use it for this project. So let's have show MAC address table regex list. Let's also have a list. We'll have actually just one there. We have area, and this will be red.compile, and then I have to parse my output here. So let's try. So question mark P, this will be VLAN number. So it all starts with white space characters. There may be 0 or more. VLAN number, this will be a number. Then you have space. I did something wrong because it doesn't recognize this. You could match lines that have interfaces. Yeah, I mean, this is what I'm going to do. I'm going to match only those. But there is some mistake that I don't see right now. It's strange. Oh, sorry. Right, so it's not a question mark, because question mark is 0 or 1. It's asterisk for 0 or more. Okay, so like this, and I will have MAC address. This will be \s big. Then there is white space. There is type. I don't really need type, but that's alright. Type. And then I have similar stuff. And this will be interface name. Okay, cool. So like this, and doesn't like something. Line is too long. No, not my problem. Okay, show MAC address table area. Okay, so now I can say this will be a little bit different. Because I want to find multiple instances of this, not single one, but multiple. So I cannot use group dig directly, but there is a workaround in Python. So Python multiple area group dict. There was some article on Stack Overflow. Fine meter. No, I think find all 4 named groups. Area find all which returns a dict of named capture groups. Yeah, so this is exactly what I need. I have one regular expression, but I need multiple instances of this. Like this. Name, which will be just a list. And you use this m group dict for m in rfi meter. So let's do dev parse show MAC address table, CLI output, result will be dict. We'll have this, we'll have this will be MAC address table, and this will be a list which will be CLI. Okay, this will be my regular expression, show MAC address table area, find iter from CLI output for match in like this. Match group dict for match in show MAC address table area, find iter. Now I can return the result. So, and now I can, and let's do the similar stuff that we did before. So result will be dict, result.update will be parse and this will be parse show MAC address table, show MAC address table, I think. Let's see. Show MAC address table. Yeah. Okay. So now I will have on the top level, I will have like a host name, and then I will have MAC address table which contains details about MAC address table. So this is all good, but we need to change it. The question was that we have to sort those. I think I can sort them right here as well in parsing. So after applying this regular expression, I will have these key values: VLAN number 1, MAC address table this, type this, and I want to sort them based on interface name. So yeah, I will have to redo this a little bit. So MAC address table will be this list, and then MAC address table sort, and we will use key function, key parameter, where you specify a function how you sort. We will use lambda x, and then x will be a dictionary, which is one element of the list. So from this dictionary I want to sort based on the interface name. So I think like this, and then here I say MAC address table, and then I return the result. So afterwards this should work. So the very last thing is that I want to, and you know what, give me one second, I want to do show MAC address table on the router and see if it works. Actually, I think it doesn't. No, it doesn't. So this part I will not be able to test anymore on my test network. I will have to do it directly on in Gen 3. So I parse those. Now I can create result, which will be a string containing, say, hostname, hostname, \n, let's do this, MAC address table \n, and then the table itself, which will be MAC address table, and then I format using let's do this result str, and I format based on, no, I don't like this variable name result here, so let's say parsed values, okay. This will not work. Because I'm returning just a list, which is alright. Let me think. So the problem here is this will be a list, and at the very end I want to have like similar text output. So how do I do this? I think there was some library, Python print as table, like this one. I can use this formatting thingy. Let me try and CLI. So let me try Python, and let's have a couple of values. Let's say VLAN number is 1, and then MAC address is AA, BBB, CCC, and now I do 15. Format VLAN number, MAC address. Oops. No. Let's have here 4. And here let's have 20. This is a little bit better. Here there are 4 symbols, and here there are 20 symbols. Like this. Okay, this can work, but then I have to change my code. Let's have here MAC address table list, and I will also create create the string. So yeah, it's not that straightforward. Let's have here MAC result str will be joining stuff, and in joining stuff we will have 4 MAC address entry in MAC address table, and then you'll have to you'll have to put all of those stuff back. This will be like this. Say 4, 17. Oh, there is one more thing that I have to test. Oh. V1 number. MAC address. So I want to use the dictionary. Okay, this works. So V1 number, then your number, MAC address, type, and interface name. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 5, 9, 10, 14, 15, 16, 17, 18, 18. Kapalua, thanks very much for following. So 18, let's see, back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So type 11, and here will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and interface name will be 10. So format, and then I expand MAC address table entry. And this should be it. And then I join for every entry. MAC address table entry for MAC address entry in MAC address table. And here I can now say MAC address table will be result str, and I can return the result, and here I will say MAC address table, and that's pretty much it. Parsed values. There's one thing I forgot, if it accepts the dictionary or I should expand the dictionary. So let me check it right here. I think it does accept the dictionary. So nope, doesn't. I have to expand it. Yeah, okay. So unpacking dictionary is done using double asterisk. Okay, this looks good to me. So I'm getting MAC address table where I'm getting the host name and MAC address table, which I already sorted. And now I should be able to say return result. Get MAC address table. So I'm returning the result. And let's say MAC address table will be get MAC address table from IP, and then I just print this. Okay. So I will copy this code and I will go to my server where I'm going to run it. And is there a virtual environment here? Yep, so source virtual and netdevops pin activate, and let's see. Let's say I will create a temporary script mac tmp.py, and I'm getting all this stuff, and I am running Python on this. Oops, yep, good point. So I have to add this to my requirements txt. Let's see, pip freeze grab decouple. Python decouple 3.1. Okay. So I have to pip install this remotely. Pip install Python decouple. Okay. Let's run this again. Username not found. Right, because I also do not have this env and YAML file. It's becoming a little bit too complicated right now. I'm going just to commit to a branch. So let's see, git branch MAC address table script, git checkout -b, okay, git log, git status, okay. So I need to add all of the stuff. I need to add script requirements txt, this script, and YAML file. Git status, okay, 3 new files, git commit create MAC address table collector. Oops. I remembered the mistake. So in the script I commented this out, and I need to use this get switches IP addresses. Status, I have to add this file again. Git commit add MAC address table collector, git push -u. Oh, I forgot the syntax. Git push u like this, I think. Origin vice versa. Let me see. Git push new branch. Each code B, commit files, git push -u origin. Okay. Git push -u origin MAC address table script. Okay. So now this change should be on my GitHub page. github.com/figo network programmability lab. So once I finish this, I will talk briefly about some stuff from Cisco Live, and then we will continue with how to do it efficiently. So branch MAC address table script. Yeah, looks good to me. Except .n file. Okay, I will have to create .n file. Okay, this looks good to go. So I have to say network programmability lab, repo network programmability lab, git pull, git branch -r, git checkout, MAC address table script, git status ls. Okay, so I go to scripts folder and I will have to create .n file and copy the stuff from here. Okay, and if I did everything correctly, this should work. What is it? Python collect MAC address tables py. Okay, I think show MAC address table. Okay, our stuff doesn't work. Amazing. So let's do this. Well, the good thing is that it got the hostname right. This is cool. So, by the way, I have here the old version of Python 3.5.2. I would need to update those. Okay. So I did something incorrectly, unfortunately. Let's try. Where is this my code? So I will copy this function. Okay, this doesn't work. Is there IPython here? There is no IPython. Let's try pip install Jupyter. I think IPython will work alright. Oh. Okay. IPython. Okay. So I need to import rea. I have to add this variable. I have to add this MAC address table right here. It still didn't work. Oops. That's strange. This intonation problem. Okay, I'm going to debug right here then. Okay, so let's do. Go here to this function. And I'm going to print MAC address table right here. So if it doesn't print, it means something is wrong with my... Of course, I'm idiot. I am idiot. So the only mistake, I think, is I didn't add here area.m. Okay. Okay. Okay, so let's commit this change, git status, git add, git commit -m, fix regular expression, say regular expression flux git push. So git pull, and let's run my script again. Nice. And you see those are sorted based on the interface here. Very cool. Cool. So this is basically what I was, what the person needed. The only problem is that it's extremely slow. So for 4 switches you have to connect. To every device. You have to execute command. This is network input-output operation I/O, so it takes a while. Creating SSH connection takes a while. So if you do the same thing with 200 devices, it will take minutes. So basically this is crap. I mean, it's okay, but it's crap. Okay, so let's just have a small break and let me talk briefly about some interesting stuff that I saw at Cisco Live. So at Cisco Live I had... Oh yeah, the comment, it's much more complicated than I expected. Yes and no. I mean, from like programming perspective, it's not so, I mean, I think it's quite easy, most of the stuff here. Just, you have to think through like what you're doing. So, for example, here, first I have to create a SSH connection and I have to use it persistently. So I should not create connection, do some command, close the connection, right? So I have to take that into account. Probably if I'm connecting to device, I also want to get its host name so I understand to each device this MAC address table refers to, or maybe some additional data, right? So I can either collect the output itself, or I can collect output and parse it. So in this case I was doing parsing. And then I collect the MAC address table itself. I am also collecting it, but then the task was I have to sort based on interface. In order to do that, I have to parse it first and then recreate the string back. So from like programming perspective, there is really not much of complicated stuff, but yes, it requires some thinking. Okay, so yeah, let's go back to Cisco Live stuff. It was in Barcelona, so quite nice city, and it's much warmer there than in any other European city during winter, so that's a huge plus. I had 4 sessions, and it was more challenging than I expected. So I had session on Monday, Tuesday, Wednesday, and Thursday. And there was a lot of like last minute checks, like that everything is the way it's supposed to work. So for me it was quite exhausting experience, I would say. So next time I will try to reduce the number of sessions so that I have like 1 or maximum 2. So you do your session and then you do whatever you want, you go around the conference. So I still had a chance to do it, but not much, because like most of the time I had to like prepare for the next day, make sure that the stuff is working. Some of my sessions were in DevNet zone and they were DevNet workshops. 2 out of 4 were DevNet workshops, and the format itself is there are like 8 or 10 computers, and attendees can come. Well, they come and they can do some hands-on. So this is the whole workshop format, and it's in open space area, and usually like computers are occupied and then there are like 20 more people or 30 more people standing behind listening to the whole thing, and those 8 or 10 people can do some hands-on. So the main challenge there is between sessions there is 15-minute break, and like you end at like 45 minutes, and usually it still takes you up to like 5 minutes to like close everything, to remove your computer, to remove your microphone so that the next presenter can come in. The biggest problem there is you have to set up computers during that break. So because they should be ready for attendees to do the labs that you wanted them to do. So this results in situation where you have to like come very early on the day or like couple of days in advance. You have to set up all the computers. You have to set up, I don't know, Docker containers, you have to set up virtual machines, and then you suspend them, you stop them, and then you have a bunch of scripts that when you come back 10 minutes before your presentation, you can just run the scripts and everything the whole environment is back. And you probably also need to do some additional checks to make sure that everything is still working. So that's quite a challenge because of that short break. You really you come in, you go, you need to have all of your scripts ready so that you can just spin up environment for those 8 computers. Yeah, this put some additional burden on the and some challenge to make sure it's done. And it's also possible that somebody will kill your virtual machine during the day or stop your Docker containers. So all of the stuff happened, or maybe computer didn't work and then during the days they change it to a new computer which doesn't have your files. So all sorts of stuff. So yeah, so we had to come in on the day at 7, 2 hours before the area opened, so that we could set up computers. That was a session called Bring Your Own Tech Engineer, and the idea there were me and a colleague of mine from TAC. We created a library with Python scripts that sits directly on ISXC. So in the latest releases on ISXC we have Python in isolated so-called guest shell environment, where you can run your Python scripts directly on your routers and switches. So we decided that we will build a library, Python library with some troubleshooting stuff, and we package that, we upload it to computer, and we showcased what it's doing and what is possible with this capability. So that was a session on Tuesday and Wednesday, and we had the same session twice. On Monday I had don't recall exact name, but it's basically an enterprise network programmability hands-on lab. It was technical seminar and it lasted 8 hours. So from 8:45 a.m. on Monday till 6:45 p.m. with breaks. So this was very challenging and very exhausting experience. Again, because we also had to come in very early in the morning, and there was 40 bots, 40 computers, so we had to connect them via AnyConnect to our lab. So doing that for 40 bots was a little, it took more time than we expected. We had to set up additional tools like Git there, because our code was in Git. So it took us, I don't know, almost 1.5 hours. So we finished just before our session started. So we started we came there at 7. We set up computers until 8:45. Then the session lasted 8 hours of true time, but together with lunch and breaks it was 10 hours. We finished very late. Yeah, and on the Thursday, which was the last day of the conference, I had my own session. So all of the sessions before I was presenting with somebody else. And on the last session on Thursday, I had my own session in DevNet Classroom, and this was the only one that was recorded from my 4 sessions. It was machine learning with Python session. It lasted like 45 minutes and it was also like an open space area. I think it was cool. I still have, I want to improve more my, presenting skills and stuff, but I think it went well. There was so many people, I didn't expect so many people to come. Like, there were registered 100 people, and then I saw a number of scanned pages was 130, and it's in open space area. So yeah, it was pretty crowded. But yeah, it's really cool experience actually to present Cisco Live. And the whole conference, like I didn't have a lot of time to walk around the conference. I was hanging out mostly in DevNet zone, where there was stuff related to programming, to network programmability. And this where also there was social media hub where most of the people from Twitter come. So I was, I spent my time there. Yeah, it was, I met a lot of cool people. I had the chance to talk with people. I saw, photos. If you are interested, you can find on my Twitter profile. I made quite a lot of photos. On one day I even won social media, I don't know, social media challenge. Basically the number of who tweets the most during the day. So yeah, that was it. From the stuff like I learned and what I was impressed, I didn't attend a lot of sessions, like maybe like 2 or 3 sessions in total. One session that I really liked was presented by Hank Preston. He's also the guy, by the way, who created a network programmability course. But by the way, it's actually a really good course. I'm like 30% through it. So the course that I'm talking about is, let's see, Cisco DevNet Network Programmability Hank Preston. Not this one, maybe this one. So this course was just developed in December 2017, so it's very fresh with a lot of cool stuff. This one, Introducing the Network Programmability video course. I will put it in the chat. Really good course. So the same guy was, he had like 11 sessions at Cisco Live. I was on one of those, and I don't recall how it was called, but it was basically about continuous integration, continuous development in networking. So he had the lab where you submit, where you basically do a change in Ansible playbook, and when you commit a change, then there is CI system that takes place, which spin ups a network in viral and goes to the spinned up network, configures the devices with Ansible. Then there is Ansible test playbook, which runs a test on the network, which verifies if the change that he was showing was just change of SNMP community string. So there was a test where you do SNMP get and you test if it works. If test passes, your build is green, and then you can commit it to master. So in this case, actually it was automatically committed to master after the build passes. So it commits to master, it configures the another production network. It does this, it runs the same test, it checks if it works or not. If it doesn't, it rollbacks the change. If it does, then you have your production network with configured change, but first it was tested on development network. So the whole CI/CD pipeline with Ansible, with Drone, which is CI system, really liked it, and this is actually the stuff that I will be doing here on my streams at some point, or maybe when we will get to that point where we are ready for this. But I really like the idea where you commit some change in branch, it spins up a development network, it does testing on that network. If everything is okay, then you are able to push this change to production, and then you will do the same thing. Like, really awesome, really liked it. I really wish the session was longer, but the whole DevNet workshop format is only 45 minutes. Then another thing that impressed me, and it was so, I did not expect it, and I was just walking by the booth and something caught my eye, and I stopped and I started talking to guys. So the project called pyATS. So this one. So this is a Python test framework for networking, but apparently it's much more than test framework. So yeah, this is the website, the docs and stuff. So I knew about this project before. I heard about it when these guys, well, at first it was internal Cisco project, but like a couple of months ago it got released to everybody. So when it was released, I stumbled upon this page, I started playing with it. I didn't really understand why would I want to use this. So I kind of gave up, and then I met the guys who developed this thing at Cisco Live. So I started asking them, okay, why would I want to use this, all of this stuff, and they started showing me examples. So apparently with this thing the main purpose of this was to be able to test anything on network devices in much faster than you would do in any other way. So apparently a lot of our internal teams use this pyATS framework to test any kind of code changes on our platforms. And they have a lot of parsers, they do everything asynchronously as well. So you can configure and you can test changes on thousands of devices at the same time. They have parsing for a lot of popular commands like show version, show interfaces, hundreds of commands. They do parsing in Python internal model regardless of the platform. So it's the same for ISXC, for IS, for XR and for Nexus. And it can use netconf or it uses CLI. So it's completely transport agnostic and operating system agnostic. So you just say in Python code or in YAML file, I want to have an IP address this, and I want to have BGP autonomous system this, and I want to announce network this. And this framework translates this to appropriate either commands or netconf RPC operations to do this on actual devices. So you do it regardless of operating system. So I saw this and I was pretty amazed. I still haven't played with it because I just returned 2 days ago. But this project will be on my watch list. This is something that I really would like to dedicate time, because it really looked very interesting, where you have this unified approach of configuring all Cisco devices, regardless if it's CLI or netconf. And it does much more than Napalm does, because Napalm has the same intent, where you specify once and it's vendor agnostic. This is the main difference, is that Napalm is vendor agnostic. This was developed mostly for Cisco devices, but you can write your own plugins for your own devices. This is available once they opened the project a couple of months ago. And on top of it, you can also do some cool testing, like the example they showed. You can specify in human English, verify 9 OSPF neighbors, verify 20 BGP routes in routing table, and they build the whole system behind it, where you can the system will actually go to device and do this test. So those tests, they are already there. So you specify in human language that I want to do this, I want to check this. This was pretty cool. Yeah, so they also have a lot of triggers, so you can specify I want to run a test if there is clear IPBGP command issued or stuff like that. They have a lot of interesting stuff. So check out their project. I really think it's worth time investment, especially the part where you can configure your whole Cisco network regardless of transport, regardless of CLI commands. Yeah, so this was another project that I got interested in after Cisco Live. What else? So I listened to keynote of, well, it's not keynote, well, yeah, I listened to keynote, to both intro keynote and guest keynote. So the guest keynote was delivered by, gosh, I forgot how this guy's name is. I think it's Bruce Dickinson. So he's a lead singer in Iron Maiden. It was pretty cool. I still like the Kevin Spacey keynote the most, but this was pretty close to it. I also listened to Suzy V and Suzy V's CTO of DevNet. Suzy V delivered an innovative talk on APIs and stuff. This was pretty good as well. I liked it. There was she, then there was Mandy Valley, and who is director of evangelist group in DevNet, and there was a guy from Google Kubernetes. I forgot his name. So 3 of them were delivering this whole talk. It was pretty good. Yeah, those are, I think, the session that I visited, so not many. But for me, the most important one is a social aspect of Cisco Live. Talking to people, not sessions themselves. I rarely go to sessions because most of the sessions you can watch recording for free. So I try to spend as most of the time for social interactions at Cisco Live as possible. Yeah, and it worked out for me well so far. Yeah, so yeah, every day I was returning pretty late, and then I had a couple of hours of prep then pretty late at night I go to bed, and then early in the morning I go to Cisco Live, and like this every day. So it was very exhausting week for me. And then before Cisco Live there was two days of DevNet Express. So DevNet Express, I'm showing you the web page right now. DevNet Express. So this formatting is broken here. So DevNet Express is a 2-day event on a couple of tracks. So there is DNA track for like enterprise space, there is data center track, and there is collaboration track. This event is held in a lot of cities. It's available for partners, for customers, and well, there are like a couple of variations. It can be targeted for our internal Cisco ICs. It can be targeted for partners, and it can be targeted for customers. So this one was for customers. So everybody was welcome there. And it was on data center. And basically it's about network programmability products that we have, on different technologies and techniques that are there. So it was pretty, it was very educational for me, because I work mostly with enterprise stuff. I don't touch data center a lot. So there was covered some programmability aspects from data center perspective. So it's really cool event. There is really great atmosphere. There is a lot of swag that you can get from it, and it's basically targeted on you doing some hands-on. So you have to go through labs, and you have to do some missions. So it's not just somebody talking, you actually have to do stuff yourself. So from that perspective, it's pretty amazing. So if you haven't been to one, I really encourage you to go to this page, DevNet Events at cisco.com, and see when will be the nearest one in city near you. So I know that they are doing, I think last year there was more than 100 events across the world. So you see that the closest one will be next week in Nigeria, and then there is one in Germany on DNA track, and then there is one in UK, so specific place for some reason, and then there is in Wien, New Zealand, San Jose and RTP, Barcelona. Oh, there will be a new one in Barcelona. A lot of them are in US, but there are also like quite many in Europe right now as well. So yeah, this is a good stuff to kind of like get familiar with what is out there. Unfortunately, I didn't have a lot of chance to like see the city, Barcelona. Like I was so busy all week long, so I didn't get a chance to see the city, and that said, like I was only on the bus tour, on 2-hour bus tour, but you don't see much there. Like there's this church, Sagrada Familia. Looks pretty amazing, but I saw it only from outside. Sagrada Familia, or Familia, this one. It's just huge and looks very great. Yep, so I also, last time I said that I will try to record a stream from Cisco Live, but I tried, but it didn't really work out. It was too busy. I have stuff, I had my microphone and keyboard, but just didn't work out. Yeah, sorry for that. But now that I'm back, we will be having those streams with the same schedule as we had before. So this was pretty much my Cisco Live Europe experience. Yeah, and you can actually see on the door I usually hang all of my badges from Cisco Live. Okay, so do you guys have any questions, something that you would like to know about Cisco Live and my trip to Barcelona? If you would like, let me know. If not, we will have to continue with our stuff. Our stream already lasts 2 hours, so I would like to move forward. Okay, so there are a couple of things that I want to do. First, I want to measure time, and let's do start time, and I will have to use. Let me get an example. I had this one, start time is equal to time.time, and then print like this. Okay, and then I also have to import time. Okay, so this looks good. So let me commit that as well, and I will show you like how much time it takes to connect to 4 switches and get the table. So git status, git status here, git add, git commit measure time for MAC address table collector script, git push, let's get it here, git pull, what? Okay, and now I run it again. Okay, so let's wait some time. Oh, so yeah, if you want to see it, let me open that. Why am I not logged in here? Oh, here. So, DMFIGL Network Programmability Lab, and then you have click here on branch, and you have to change the branch to MAC address table script. So if you do this, and then you go to scripts, you will be able to see this collect MAC address tables.py. Okay, so it took 22 seconds, and believe me, if I add more outputs that I want to collect and more devices, it will take forever. So how we can change it? There are a couple of techniques. Well, there are actually like 2. One of them is to use threading. and with threading you spawn up a bunch of threads and you do stuff, and excuse me, so you spawn up a bunch of threads, and then that's basically it. So for every device you spawn a thread and you run it in a thread, and then you collect output somehow. Well, there is another technique similar to this, which is called multiprocessing, where instead of creating a thread, you fork Python process, so you create a new Python process, and then you can leverage multiple cores. So there is much more to it than I would explain right now. Basically, you would use multiprocessing for stuff that is bound on CPU. So the stuff that your program runs slow because of your CPU. In those cases, you may use multiprocessing to use multiple cores on your computer. With threading, you always use one core, and scheduler decides on its own where it will switch from one thread to another. And because Python has what is called global interpreter lock, or GIL, only one thread may run at the same time on one core. So you have to switch threads. It leads to situations where if bunch of threads write or read the same resource, you create race conditions. And very typical example is actually with either a file or with printing something on the console, because std out, standard output, is a single IO resource. So when you try to do this in threads, you will see that you will have a mess. You'll have partial output from one thread and then partial output from another thread, if you don't use proper techniques. So if you absolutely have to do this, you need to do two things to make threads safe without racing conditions. First one, you have to use queues, where and whenever you need to do something with single resource, only one thread should be able to do something at the same time. So what I mean by that, if you want to print something to std out, the way it's supposed to work is that your threads have to push stuff on the special queue, and then there should be another thread which will be, let's say, print executor thread, which the only thing it does, it prints to the std out from the queue and removes element from the queue. So only one thread writes something to one IO resource, and then it could be safe. Another technique that you need to use is called a lock. So whenever you need to do something sequentially, you acquire a lock, so the context cannot be switched to another thread, and then once you're done, you have to release the lock. So here is a challenge. Writing, let's say, creating a concurrent code with threads is very simple. You will see it's just a couple of commands, so a couple of functions you call here and there. However, to make the code with threads safe, it's actually much harder task than you would expect. So whenever you deal with any kind of IO resource, you read write to std out, you read write to the file and stuff like that, you most likely you are creating race conditions that if you don't handle, you will be in deep trouble. Yeah, and basically a lot of people do not know how to do it safe, by the way, including me. So I barely use threads just because I don't have a lot of tasks. So I know them not very good, and I try to stay away from threads because I don't feel comfortable yet to write thread safe code. And I obviously tried a couple of times, but it really depends on the task. So some tasks you can write thread code with a couple of lines and everything will work great. Some other programs, if you do this, you will be like completely screwed. So I try to stay away from it personally until I have a task where I really need to use threads, and I will have to learn those. Another technique, so yeah, let me reiterate again. You would use threads if you have usually IO tasks. So whenever you run, if you do some kind of network operation, or if you do database operation, doesn't make sense to really use multiprocessing. It makes sense to run threads. But if your task is CPU bound, I don't know, you do a lot of calculations and this is a bottleneck in your program, then you would use multiprocessing to parallelize using your multiple cores. So this both like threading and processing still will be what is called like synchronous code. There is another technique called asynchronous programming, and it has been out there for a while, and it has been out there in Python for a while as well. But they reintroduced in Python, they put it in standard library called asyncio in 3.5. So before that, there was some people trying to do asyncio with framework like Tornado. But in 3.5 basically it was included in standard library, and this is where people started like, oh, I need to write async code. So what are the benefits of async code? In async code you have single thread by default and single process. So you don't have any overhead for threads, you don't have any overhead for handling multiple processes, you don't have forks, all of that stuff. So it's very lightweight way to do concurrent tasks. Second thing, you are the one who can control the context switch using await statements. You'll see it a little bit later. Third thing is, well, these two things already like worth exploring why you would want to use async IO. So like it's very fast, it's very lightweight, and it's very fast even though it's single thread. So from that perspective it's awesome. So there was some tests that are like trying to run as many connections as possible on socket, and I think IO just beats everything else. You cannot run millions of threads. Your computer will not be able to handle that. Basically, if you have too many threads, at some point your overhead is so high, so whenever you switch a context you don't get any gain because you waste resources on switching the context and managing the threads. So after some number of threads, and there is no definite way like it depends on the program, but like if you have more than hundreds or thousands of threads, you know it doesn't scale well. And asyncio scales really well. The problem with asyncio is it changes the tooling that you have. So you can't write the code you wrote code before. You have to change it, you have to use new libraries, you have to, whenever you do any kind of IO operation, it should be asyncio, it should support async technique. You have to create your new functions, which will be async functions. So basically it's not an easy task to migrate from synchronous code to asynchronous. So this is probably the main disadvantage, and you have to learn a lot of new stuff, and the documentation for asyncio itself right now is not very good itself. There is like 40 pages on official Python page, and it's really actually hard to understand. So you, instead of reading docs, you're trying to watch some courses, you're trying to watch some presentations at Python conferences and some other stuff, and blog posts, to read blog posts to understand how it is working. So yeah, this is like overview of threading and asynchronous programming. So let me start by threading. Oh, and there is additional library called concurrent.futures, which is a high-level wrapper for threads and multiprocessing. Yeah, it's an easier way to use threads and multiprocessing, but it doesn't eliminate the problems that you may have with like queues and all of this stuff. So this is what I'm going to use right now. So I'm going, oh, and by the way, you saw that this took 22 seconds. So I will use library called concurrent.futures to launch a bunch of threads. So in this library we will use map function. I don't know if they have map example here. Yeah, right here. So they use executor map on, this is a function name and this is arguments. One of the interesting consequences of using something like map with concurrent features is that probably you will need to return a tuple with your input argument and result. Because otherwise, you know, you will not be able to like track it correctly. So honestly, as I told you, I'm not really professional with spreading. So let's start doing it anyways. So I'm going to we'll have a new function here which will collect some other outputs. So no. Okay, so let me import from concurrent.futures import thread pool executor. In main I will create a pool. So create a pool which will be thread pool executor max workers, let's say 4, so I can launch 4 threads at the same time. And then I want to find some good example. Concurrent futures map example. There is this guy. See. Using map is basic thread pool. So you have a function which is called task here, which takes a number and returns a number divided by 10. Thread pool executor max workers 2 main starting, and then you map tasks and you provide an input arguments, and this will be your results. Well, actually this is not 100%. No, this is correct. Okay, so you have results. So thread pool executor manages a set of worker threads, passing tasks to them as they become available for more work. This example uses map, can produce set of results. The task uses time sleep to pause. I don't recall if this is ordered or not ordered, and this is what I need to find out. Both executors have common method map, like the built-in function. The method allows multiple calls, passing each of the items in an iterable, except in this case the functions are called concurrently. In multiprocessing, this iterable is broken into chunks. So this will be pool.map. Then you put a function, and then you put iterable. So my function will be get MAC address table, and you know what? I'm sorry, but I have to change this a little bit. I want to save this script the way it was before. Let me save it the same way. So here I will say, we'll copy this one, and let's say it will be threading. And now I can do this. From concurrent futures import thread pool executor. So I have pool 4 workers, and I will do map. Oh, I need to get the list, and I map function name to IP list. And this will be, let me open documentation for this concurrent futures map. Map, similar to map function except the iterables are collected immediately rather than lazily. Function is executed asynchronously, blah blah blah. It's returned iterations using small chops. Looking, what does it return? I think it returns what is called future, but I don't recall 100%. Okay, let's just have results, and now I can say for result in results, I'm going to print results. So hopefully this is correct way, but I'm not 100% sure. Okay, so ready. So let's see. Git status, git add, git commit m, add MAC address table collector. This threading. Okay, push. So remember, git checkout minus b threading. Yeah, that would be okay. Okay, so let's see. Git pull. Okay, so let's also write this down. So let me open the Scratch file. So for switches, 2 commands, show version and show MAC address table. This is the time it takes. For switches plus threading. I hope that I did it correctly, but you never know. Threading. Let's see. Whew. Nice. So the same output, and now it takes 6 seconds. 6 seconds. So let me show you, something that is really important to understand, like super important. My thread is called here when I say pull map. Basically, the way pull map works, you give it a function and then you give arguments with commas. So, well, actually not exactly. You give an iterable. So what this map function does, it takes every element from IP list and it passes it as a function to get MAC address table. Now, basically, get MAC address table and IP from IP address list. This is a function that is done in threads. Now, if I did some printing here, this is where would everything go wrong. This is where I would have a race condition. So with this abstract thing that our concurrent futures comes with, it comes with this map function. So what I did, I collected all like tasks in a list, and then I can, I get results from these tasks from this iterator object. And you see that I printed them in the main thread. So I printed all of the stuff in the main thread. So this is okay. Remember, I told you only one thread can print safely to one IO resource. So this is what I did. I print everything back in the main thread. So first I collected all results and then I printed them. Now let me show you what will happen if I do print somewhere here. This will be like a mess. I will even create I can change this one. So vim collect MAC address table threading py. So imagine you're trying to debug something, okay, and then you do print statements. Good luck with that. So oops. So here let's say print parsed values dot, well not dot but MAC address table and parsed values MAC address table. Okay. Oh no. So and then I want to comment out here. So that it's not complete mess. Let's see. Look at this. Well, I didn't have any additional spaces, but you can see that there is something that just went. No, let me add some additional stuff. Let me add the host name there as well. No. Okay, so let me change this a little bit. I will actually print this whole output that I return. Say, and here, and I will print here result. Yeah, so this allegedly, and I will also print like this, let's say 80 times, so 80, so there is like separator. Okay, let's run this again. Observe. Look at this. So there is this output, and then there is this one, and then there is other address tables, and then there are here the separators at the end. Let me know what you think in the chat about threading and stuff. And I saw this people doing this all the time, like stuff like that, and then they ask, but you know, why it prints garbage like this? Well, yes, because you are creating a race condition in threads. So what I really like to tell people is that before using threads, you better read the theory about threads, otherwise you will end up in scenarios like this. And yeah, so threads also like make debugging more complicated, so like you cannot just use the print statements, you need to do something else, because if you do print statements inside of the threads, you'll see this. So debugging code with threads in Python is quite hard. Let's actually run it again, just for laughs. And you see now, this one printed alright. Typical race condition, so where, you know, basically you don't have consistent output anymore. This one went fine as well. So you saw, right, that, you know, I didn't change any code. Oh, now it's race condition again here. Oh, and there is stuff here where I switch the context during execution of print function, and basically this end of line character got lost, and then it's right here at the bottom. So threads are dangerous if you don't understand what you're doing. Guys, let me know in the comments if you have any question on this, if you want me to clarify something more about threads. So whenever you use threads, you should be extra careful. You should think logically where you may create race conditions and how you would need to handle them. Because, and you know, this is a print statement. If you would write to the file, or even worse, you would do some stuff with the database, good luck with that. I mean, you know, without logs, you would be in deep trouble. Okay. So yeah, I ran the same program a couple of times and there is different output all the time. So let me revert back. So git reset hard. Can be hard reset with the pass. Git reset. No, it's git checkout, I think. Checkout. Okay, so now it's back. Let me check. Okay, no print statements anymore. Okay, so remember, any IO operations with threads you should do in separate thread or in main. Well, main thread is a separate thread as well. So in this case, I'm doing print operations only in the main thread. So I will run this again just for the test. Okay. So last time it took us around 5.8 seconds. Okay. So you see there is quite an improvement, but you can also see that we are using only 4 switches. If it would be like thousands of switches, this time would be enormous. This would be linear increase. With threads, the time will increase, but not a lot. So maybe it will be like, I don't know, 6.5 seconds. Now, the last one, it will be asyncio. You will have to give me the error so that we could troubleshoot it. Yes and no. So what you're saying is correct, but I will not use multiprocessing because for IO bound tasks there is actually almost no reason to run to run multiprocessing? Well, first, multiprocessing adds a lot of overhead, like forking, right? Second of all, it is much harder to. There are some interesting stuff with variables that you pass, with like shared variables where they are serialized using pickle, and it leads to interesting consequences when you use, like when you have like database connection or you have SSH connection, stuff like that. If you don't use it properly, you actually cannot use, let's say if you create a connection once and then you pass this connection variable inside your fork, it will not really work, especially with databases. Second of all, and yeah, I mean, why would you want to use multiple cores for tasks that are stuck in I/O, really? Yeah, Roman, so your this error comes because you don't have .n file like I do here. So you need to create .n file in the same folder, and you need to add your credentials for devices. And then also, obviously you need to have Python 3, but I see that you're using Python 3. And you need to do pip install. So here I have requirements, oh, not here, in scripts. I have file requirements.txt, so you also need to do pip install -r requirement.txt, so all dependencies are there. But most likely you'll already have them. Okay. So yeah, in this case, using multiprocessing doesn't really make sense, at least from my perspective. First, there is no reason to, well, yeah, it's not first, because I already listed a couple of reasons. Also, you cannot actually go more than the number of cores that you have, right? So creating 20 processes will be, you can do it, but your performance will be even worse. So you need to be even more careful when you do multiprocessing. So this case, because we are bound on I/O operation, on SSH connection, makes sense to use threads. And now we will try to do asynchronous programming, where we use a single thread, single process in very lightweight fashion, lightweight manner. It will work. So the main problem is asyncio, as I already told you. It changes the tooling, so you have to change your code quite significantly. You have to use new libraries. So let me do this. So I will have a new file called async. So instead of netmiko, which is our library here to do SSH connection, we need to use async SSH library, and there is a library called Python, so netdev. Let me find this guy. Perfect. Yes, this guy. So this guy wrote a library which is very similar to netmiko, but it uses async. And it also supports a bunch of equipment. On the background, it uses the library called async SSH. So async SSH is very similar to paramiko, and this library netdev is very similar to netmiko, basically. And here is an example. So let me do this. I don't know why I still have this one. So I don't need concurrent features. I need asyncio. Import asyncio. And then I need from netdev. I need to use create function. Import. Let's just import netdev. Import netdev. So one thing that we will have to change, we'll need to change our get MAC address table a little bit. This will be async function now, so we have to specify explicitly that it's async. We will have to do await. Oh, we will have to use async with SIS. Okay. So here this will be a little bit different. So it will be with async with netdev.create. And you see that he is using, instead of IP, it uses host. So let's do host here. And netdev create. This will be device parameters. As a device connection, and then you use await whenever you use send command. So I will put this to the top, and here I will do a little bit differently. So let's say show version output will be await on device connection send command, and then this one partial version will be show version output. Then and then show MAC address table output will be await on this one. And then I have to say here that I could do it in one line, but it will be just big line, so I don't want to make it too big. So then we do async. And I don't need to disconnect, so there will be now this one, and then I will be in the block async. So pretty much the same stuff. This block a little bit different. So with async you have to create a loop. Loop is basically something that runs repeatedly, and then you create what is called coroutine. And the idea behind coroutine is that whenever you call coroutine, it returns immediately and it's not run. So whenever you run this function, this one, with any kind of argument, it instantly returns. So it doesn't actually do anything, really. It just creates a coroutine object. So it's not really run until you actually start it. So you create this coroutine object, and then you wrap it in what is called task. So this is just a wrapper through which you can either do something with coroutine, you can advance coroutine, or you can catch an exception in coroutine, and coroutine returns an exception when it ends. And through this like future, this is how it's called, and this will be quite hard to explain it right now. There is a lot of theory behind it, but basically you will have to wrap up your coroutine object in future, and future can have a result, and you can basically, you say, I have a function that I would like you to run at some point, but right now I want to have a placeholder for this function, and then when you will finish, you will have to return a result to me or an exception to me. So this is an idea behind this like future thing. So you will create the tasks and you submit them to this loop, which actually will run the tasks, but the tasks themselves are returned immediately. So you have these tasks objects which are features, and then loop will end once it finishes all the tasks, and at that point your tasks will have a result in task.result. So it's one thing. Second thing is with this await statement, this is a point where you allow switching the context. So unlike in threads where the contexts are switched automatically, here they are switched whenever you have this await statement. So you are in control when you want to switch them. Usually you would want to switch them when you have IO or IO tasks. So in this case I'm sending command and I'm waiting for the output from command. So I am returning back control to the loop so it can run some other thing. So this is basically an idea. So I will not have this pool anymore. I will not have this map anymore. But I will have what is called loop. So loop will be asyncio get event loop. And then I have to look up my examples that I had a couple of times before. So I will have to create tasks on the loop for the command. And then I have to say a loop run until complete. Okay. So I have to create tasks. And my tasks will be loop create task and the function that I want to run, which will be get MAC address table for IP. For IP in IP list. This will be my tasks, and then I run my loop run until complete, and then I have to await on the tasks. So is it wait? Yeah, it's wait on tasks. So this statement says you should end the loop when all tasks are finished, and basically when you stopped waiting on all of the results from all the tasks. And then for task in tasks, you can print task.result. It's basically this idiom. So, and that's pretty much it. I will give you some more time to look on this code again. You create a loop here, you create the tasks which are based on coroutine functions here, on this coroutine, and you wrap this coroutine into the task right here, and you have a list of tasks. This is executed immediately, and this does not launch the tasks yet. And then in this statement right here, you say launch the tasks and stop the loop when you finished with all the tasks. And like finish task mean it either returned a result or it threw an exception. And then for every task in this task list, you can get a result from this task. Okay, cool. So I'm pretty confident this will actually work. Okay, so let's do this. Git status, git add, git commit, and add MAC address table outputs collector asyncio git push. Okay. Git status, oh, git pull. Okay. Let's see. Look at this. Look at this time. Where is it? Let me show you that the output is the same. I collected 4 MAC address tables in 0.6 seconds. It's like 5 seconds faster than with threading, and it's only 4 devices and 2 commands. If we are talking about thousands of devices and a lot of commands, man, this gain is like amazing. So yep, let me see. Let me run this again just for the test. Yep, pretty much the same output. Output here is sorted the same way it was before, and it still takes 0.59 seconds now. So asyncio is pretty amazing technique. It obviously requires more skills and requires more understanding about these loops, about these tasks, about coroutines, how to write synchronous functions, all of that stuff requires, you know, some learning. There is a learning curve, but in the end, this is cool. Like when you see this runtime, 0.5 seconds, it's like Ansible will not be able to do it in this time. For example, Ansible uses threads, I think, if I remember correctly, and it has a lot of additional stuff on top of it. So I mean, Ansible has a little bit different idea, but you can see that with pure Python and asyncio you can write this very fast. And with, even if you would have thousands of devices here, it will not take much more time, because the way the context switch works, it's very lightweight. On every IO bound operation you switch the context, so it will be very fast even with thousands of devices. So yeah, this is pretty much what I had for today. I will stay a couple more minutes for your questions and stuff. We already approached more than 3 hours of stream. And the attendance also dropped, so I think it would be a good point to wrap up. This is definitely not the last stream on asyncio. You know, again, I went through like the whole process of creating this project that I had for one of my colleagues in Router Gods, and probably sometime some other stream I will spend more time specifically for asyncio explaining the stuff, what is coroutine object, what is loop, what is task, what is future, what is run until complete, and stuff like that. Yeah, probably, yeah, it should be interesting. I actually submitted a session for this for Cisco Live US. I really hope that it will get accepted. We'll see. That would be pretty cool to talk about like asyncio and stuff like that at Cisco Live, because for us as a network engineers, this is a pretty common task to do something on thousands of devices. You know, our area just requires this. So for example, I don't know, depending on your task and area of application, you may not need threading and asynchronous programming, but in our specific area of networking, we always deal with big networks with a lot of devices, so having this tool in your arsenal is pretty amazing. So yeah, I encourage you, if you are interested, to spend time on reading documents and blogs and watching some videos on YouTube, so that you can get more proficient with this. Okay. Any questions, something that you would like to know before I wrap up for today? Let me see in some additional chats if I have any questions. I don't see any questions. Okay, then we are good to go. Thank you very much, guys, for spending time with me on this Sunday night or morning or afternoon, depending on where you are. And see you next week, see you next Sunday, and I will give an announcement of what we'll be doing next time via Twitter, as always. Thank you very much. Bye.